division of two complex number, we've already said that z1 is this and z2 is this. Okay, then division z1 over z2 will be what? Will be r1 cos theta 1 plus I sine theta 1 all over r2 cos theta what? Theta 2 plus I sine theta 2. Okay, so how do we do the division for two complex number? Very simple. So what we do is to get the conjugates of the denominator, and that is cos theta 2 minus I sine theta 2. When we are talking about conjugates, the conjugate is that same expression, but the sign we alternate, we reverse itself. So I'm using the conjugate now to multiply both the numerator, which will be cos theta 2 minus I sine theta 2. Use the conjugate to multiply the top, the numerator, and denominator. So the numerator times the conjugates, the denominator times the conjugates. So that will now be, we now have z1 over z2 equal to r1. Then we have what? Cos theta 1 plus I sine theta 1. Then cos theta 2 minus I sine theta 2 all over r2. If you check this one, and this one, the same expression, but this is plus, this is minus. So when you have the same expression and alternating sign, then we call it difference of two squared. So in that case now, I'll not waste the time there. I'll just apply that straight away, and that will be what? Cos theta 2 all squared, then minus I sine theta 2 all squared. That's the difference of two squared. Note, it's a minus b into bracket a plus b. The same expression, but alternating sign, and that will give you what? This one, first one squared, a minus 1 is squared. Okay, so that's what I did there. And this one will give you what? Cos squared theta 2, which is minus 1, times this one. That will what? That will be plus sine squared theta 2. For the trig identity, the angle here must be the same. Once the angle is the same, okay, then this is what? 1. It could be cos squared 5 theta plus sine squared 5 theta. The angle must be the same thing, and that will be 1. So the denominator is, we've gotten this expression. Let's quickly multiply this expression. I will copy it here, cos theta 1 plus I sine theta 1, and then times cos theta 2 minus I sine theta 2. So this one times this one, that's what? Cos theta 1 cos theta 2. And this one times this one, so that's what? That's minus I cos theta 1 sine theta 2. And then this one times this one, so that's plus I sine theta 1 cos what? Cos theta 2. And then finally, this one times this one. Plus times minus, that's minus. Then I have what? I have I squared sine theta 1, and then sine theta 2. And don't forget that this one will become plus. We can put the real part together. We have cos theta 1 cos theta 2. Then this one here, that's a plus sine theta 1 sine theta 2. So that's that. This I squared minus 1 plus this one. So this one now comes to real part. Then this one also real part. So that's that. Then this one here. So we now have plus I. Let's write the positive first and factorize the complex number. Is here. Complex number is here. Is here. I mean, I is here. I is here. So we have I, the complex number, outside, and that's what? Sine theta 1 cos theta 2. Then followed by the other one, that will be minus cos. I mean, this one. Minus cos theta 1 sine theta 2. Close that. Okay. So that's what we have now. Then this will be equal to this one, and this one is non-identity. That's don't forget cos theta 1 minus theta 2 is equal to cos theta 1 cos theta 2. Then if you are dealing with cos, this will come plus, so plus sine theta 1 sine theta 2. So these two expressions here is what? E cos theta 1 minus cos theta 2. And then this one also, that will be plus I, and that will be what sine theta 1 minus theta 2. So z1 over z2 is equal to, that will be r1 over r2 cos theta 1 minus theta 2, cos theta 1 minus theta 2, and then plus I sine theta 1 minus theta 2. That's the division of two complex number, where r1 over r2 is the modulus, theta 1 minus theta 2 is the arg z of the argument. That's the argument of the complex number. Okay, so that's that on that. I just want to quickly, on this case here, on the sine theta 1 minus theta 2 is equal to sine theta 1 cos theta 2 minus cos theta 1 sine theta 2. And that's what we have there. Check the format. You can see sine theta 1 cos theta 2 minus cos theta 1 sine theta 2. So it's just an identity we use there. And that's that on the division. So let's quickly go to multiplications of two complex number in exponential form. If z1 is this form, in exponential form, you have this, and your z2 is let's call this one r1, this one r2, let's call this one theta 1, theta 2. Okay, the multiplication was z1 z2, and that's what this one times this one, that's r1 r2, and then this one times this one, that will be exponential. We can factorize that, that will be theta 1, that's what theta 2. Okay, so that's that on that case, because we apply indices to this. So where this one is your modulus, theta 1 plus theta 2 is your arguments. So that's that on that. And you can quickly do the divisions for this case also. You can do the division also. Okay, so z1 over z2 will be equal to what? r1, this one is theta 1, r2 exponential theta 2. So this will be equal to what? r1 over r2. And when you are dividing, don't forget the indices. Okay, the bases are the same, so you pick one of the bases and then you subtract the powers, and that's what I is common. That will be theta 1 minus what? Theta 2. So that's our division of these of this form, where this is your modulus and this is your what? Is your arguments. Okay, so the next thing you do now, because if you don't solve questions, you will not enjoy this topic. Okay, so the next thing we want to dive in now is question solving. So please join the next video on solving questions involving multiplications, divisions, and exponential form.